All right, so these are your notes for section 3, chapter 6 in geometry, and we're going to talk about indirect proofs. So the objectives say to write indirect proofs in paragraph form. I'm going to be a little loose on that because I'm not really going to require complete sentences for these because I'm probably not going to write them either. But you do have to follow a structure and use the correct form to write these indirect proofs. So these steps here, 1 through 4, you need to fill those in your notes. I'm going to assume that maybe you'll pause to do that because I'm just going to start talking about those things and go with it, right? So the first thing you have to do is you have to say, assume temporarily the opposite of whatever it is that we're trying to prove, right? So if there's an if-then statement, if P, then Q, I'm trying to prove Q, right? My conclusion is the thing that I'm trying to prove. So I needed to see that kind of for my own purposes when I was doing this work or learning this work. So I figure you would probably need that too. It's always the then part of your statement that you're trying to prove. Otherwise, you can see an example on the right over here. It tells you you're trying to prove that x is not equal to 4. But if that was written in an if-then statement, it would say if 5x plus 3 is not equal to 23, then x is not equal to 4, right? So that given is the if part of your statement. The prove is going to be that, the then, right? Number 2, you start reasoning logically until you reach some kind of contradiction, until you figure out what is wrong with your argument, right? Once you figure out what's contradicting a known fact, that's when you can say, oh, therefore, the assumption is false, right? That's required. You actually have to say those words. Therefore, the assumption is false, right? But that being said, I don't actually say therefore ever. You can see these in your notes too down here. Those 3 dots mean therefore, so don't do that twice. Next to those 3 dots, don't write therefore, because then I'm saying therefore, right? Don't double it up. Just write it once. So I don't need to do that. I'm going to erase that, but just so you understand. But I'll say therefore the assumption is false, and whatever I said before, right, must be true. Whatever is opposite of what I said before must be true. So I know that sounds really weird, but when you do some examples, it actually starts to make a little bit more sense. So I'm going to jump into this one right away. Just changing colors here. So I'm trying to prove that x is not equal to 4. So I'm going to assume temporarily, so I need to write that, assume temporarily. I'll abbreviate it at least that much. But that x is equal to 4, because that's the opposite of what the proof actually says, right? What I'm trying to prove. So I assume that x equals 4. And then I try and prove how that contradicts the given, right? Some known fact. So I'll plug in 4 in this case, 4x, because this is just an algebra problem. So I know that 5 times 4 plus 3. So 5 times 4 is 20 plus 3. Oh, that's 23. And I was not supposed to get 23 because literally it says not equal to 23 up here. So already I'm contradicting that given, right? So if I'm being really formal, I can say which contradicts the given. And then I'd be saying, therefore, again, that's what those dots mean anyway. Therefore, the assumption is false. And that means that x equals 4, right? So that was the point of this proof to begin with. So it was to prove that x does not equal 4, excuse me. I forgot to put a mark through my equal sign there. But I'm trying to prove that x is not equal to 4, and I proved it by showing that it can't equal 4, right? My next one here. So I have Aaron who's on the AB honor roll, right? I'm trying to prove that Aaron has no C's or had no C's last semester. So the first thing I'm going to do is I'm going to assume that temporarily that Aaron did have a C. Or had some C's, right? Now, if that's true, then he could not be on the AB honor roll. And that's what contradicts my given. Right? It's not possible to be on the AB honor roll if you've had a C. So therefore, the assumption is false, and Aaron had no C's. So again, I'm just trying to prove, right, by disproving the opposite. This is exactly what we were talking about when we introduced those contrapositives and talked about how they're logically equivalent. If I can prove that the opposite, right, is not true, then it is also true. So in my next example here, I had to make a little adjustment there, so make sure you do that yourself. This was supposed to say not parallel. A is not parallel to B. So make sure you do that yourself. But I'm going to go through and one more time, right? Assume temporarily that A is parallel to B. So that's the opposite of what my prove really says. Then, because those angles 1 and 2 are corresponding to one another, angle 1 would be congruent to angle 2 if those lines were parallel, if A and B were parallel. Again, we know that that's because corresponding angles are congruent if and only if parallel. But I just need to maybe say, oh, they're corresponding angles, because otherwise this isn't a regular proof. I don't have to actually list out every step. I just need to logically conclude that, oh, this doesn't work anymore, because that contradicts the given, because 1 was not supposed to be equal to 2. And that's how I know that this isn't going to work. If A was parallel to B, then 1 and 2 have to be congruent to each other. So now I can say, therefore, the assumption is false, and A could not be parallel to B, right? So when you're doing this on a quiz, on a test, whatever it happens to be, right, you get points for talking about, for saying, right, assume temporarily. You have to say those words, right? You would get a point for flipping, right, that prove, showing that it's opposite of what it was before. And then you'd have a couple points maybe for the evidence that you're going to give, whatever argument you're going to make based on why that isn't going to work. And then finally, you'll have to say, therefore, the assumption is false. And then you'll have to know A is not parallel to B in this case. So there's quite a few points involved in these things, but it shouldn't be very difficult for you to get those points, right? A few of those points are automatic. If you say assume temporarily, if you use the right form, then you're going to get a few points right away. But otherwise, you do need to understand theorems and concepts that we've taught previously to do one of these proofs. But you don't have to always list out every specific step of said theorem, or, right? You remember some of our proofs before took 8 steps to prove something specifically. But here we can jump steps. We just need to understand the overall idea, right? So as long as you get the main ideas in there, it should be good enough, right? All right, so hopefully that's good enough to get you going.